Okay, so these are the notes for section 5.5. It's going to be adding and subtracting rational functions. So just a quick recall up here is when you're adding and subtracting fractions, they have to have a common denominator, right? So the denominator is the one on bottom. So those are the same. Therefore, now I can just, I like to make this a plus, and I'll move the minus on top. So once the denominators are the same, that is the denominator of the whole fraction. Then on top, I can just do 9 minus 3, which is 6. You should always simplify a fraction. So 6 over 16, they're both divisible by 2. So it will become 3 over 8 simplified. Okay? When in doubt, you guys have a calculator, so use it to check your answer. All right, here. The denominators are not the same. One is a 5 and one is a 3. To make them the same, we have something called a least common denominator. What is the smallest number they can both be turned into? 15. In order to do that, multiply the top and bottom by 3 of the first fraction, top and bottom by 3 of the second fraction. So now both denominators are 15. On top, 3 times 3 is 9, and then I have a plus. 1 times 5 is 4. Is 5, sorry. So then 9 plus 5 is 14, getting ahead of myself, over 15. This doesn't simplify, so we're done. Okay, so now, since this is algebra, of course, it's not going to just be numbers. It's also going to be letters, okay? But same idea. Are the denominators the same? Yeah, they both are x minus 3. I notice there's a minus in the middle, so I like to just pull that up to the top and make it all one fraction. So I say, okay, the denominator is x minus 3. On top, I have 2x minus 6. The only thing left to do, just like with simplifying all of our other ones, like I would have given you a problem that looked like this and said, simplify it. So on top, I take out a 2. I'm left with x minus 3. And on bottom, I have x minus 3. Once it's factored, if you have a factor that is on top that's also on bottom, you cross them out. So this answer is just 2. Okay? Look at number 2. The denominators are the same. So that becomes the denominator, and I'm going to combine everything on top. Again, I like to just move the sign up so that I can see it. So I have x squared plus 8x plus 16 over x plus 4. Now, that needs to be factored. What does that factor to? X plus 4, x plus 4, right? Because that multiplies to 16 and adds to 8. One of these cancel, and you're just left with x plus 4. Okay, so now in this next one, check the denominators first, because this is a subtraction problem, right? They are the same, so I can just focus on the numerators. Again, I'm going to move that sign up top. 7x minus 4x is negative 3x plus 9 over x minus 3. Okay, the new stuff, the subtracting part, is done. Now I need to factor. Is there anything I can take out of the numerator? Sure, I can take out a negative 3. If I do that, negative 3x divided by negative 3 is x. 9 divided by negative 3 is negative 3. So on top, that actually factors to negative 3 outside, and then in parentheses, x minus 3. Then on bottom, I have x minus 3. Those x minus 3's cancel, and I'm just left with negative 3 as my final answer. So this is adding in a new step, the whole combining like terms, but then it's just what we did last time where we factor and cancel. Okay? What happens though when they're not the same? First, I need to factor to make sure, or to see like what the factors are. So like this one, x minus, and number 4, x minus 2 is already as factors as it can go. This one can actually take out an x, and then you're left with x minus 2. So I can see the first fraction has a denominator of x and x minus 2. The second fraction has a denominator with just an x minus 2. So they both have an x minus 2, but this one doesn't have an x. So I need to multiply top and bottom by x, right? So now that the denominators are the same, I focus on my numerator. I have 6x minus 12 on top. The order doesn't matter. I just like to put the variable first. And now both fractions on bottom, I have x and x minus 2. Just write it once. Once your denominators are the same, you just write it. Now you want to check to see if it can factor. So on top, I can take out a 6. If I take out a 6, 6x divided by 6 is x. and then I have a minus. 12 divided by 6 is 2. And then on bottom, I still have the same thing, the x and the x minus 2, because I already factored it. So notice there's an x minus 2 on top and on bottom, so those cancel. So my final answer is just 6 over x. Okay, I always like to box my final answer since there's so much work going on around it. All right, we are on to another adding problem, so I have to check that my denominators are the same. They are not. The first one has an x plus 5. The second one needs to be factored. This would factor to x minus 5, x plus 5, right? So notice, they both have an x plus 5, but the first fraction does not have the x minus 5. So I need to multiply by x minus 5 on top and on bottom. Now they both have a denominator of x minus 5, x plus 5, so I write that as my denominator, and I focus on the numerator here, okay? So I have this x, it needs to be multiplied times the things inside. So x times x is x squared. X times negative 5, oops, that was a negative 5, looks like I just changed it, is negative 5x, and then I have a minus 50. So that's what I have on top, but I'm not done yet because that needs to be factored. So you have to think what multiplies to negative 50 and adds to negative 5. It's going to be negative 10 and positive 5, right? And then on bottom, I still have x minus 5, x plus 5. I have an x plus 5 on top and on bottom, so they cancel. So I'm just left with x minus 10 on top, x minus 5 on bottom. So again, these are hard because they have so many steps. They have this new step of finding a common denominator, then the old stuff of factoring, and then the step from last class where we had to simplify. So lots of stuff here. Okay, and then we have verse, oh there, 6 and 7. So I'm going to get you started and then maybe pause it or just kind of run through them a little faster. So factor first because we want the same denominator. In number 6, this is already factored. This one is not, right? So what multiplies to negative 12 and adds to 4? X plus 6, x minus 2, right? So now I see that both of my fractions have an x plus 6, but the second one does not have the x minus 2. Okay, I also notice there's a minus in the middle, so I'm going to move that minus up with the negative 2, and then I'm going to focus on the numerator here. Okay, so if I distribute this inside, that becomes what? Negative 2x plus 4, and I still have the 10 and the 3x. And then on bottom, I'm going to have x plus 6, x minus 2. All right, and then it's ready to combine like terms. So again, they're getting harder because we're adding a bunch of old stuff into one problem. So 3x minus 2x is just x. Negative 10 plus 4 is negative 6. And then on bottom, I had x plus 6, x minus 2. So even though they look the same, like there's an x minus 6 and an x plus 6, you can't go any further. So it's actually as far as we can go. All right, 7 is different than anything we've done so far because there's only one term on bottom. So the first thing I'm going to say is, all right, what number do 3, 6, and 9 all have in common? The smallest number they can all divide into is 18, right? So maybe you start by saying, okay, the smallest number I can turn them all into is 18. One of them has an x, and the other has an x squared, so they all are going to have to get x squared. Nothing can get smaller, so you can't say, oh, I'm going to turn them all into 3, or oh, I'm going to turn them all into an x. They have to, their only option is for them to get bigger, okay? So how do I turn 6x into 18x squared? I need to multiply it by 3 and an x. On top, 3 and an x. On the second one, it has a 9x on bottom. So I need to multiply times 2 to make it 18 and an x to make it x squared. If I do it to the bottom, you got to do it to the top. The last one is a 3, already an x squared. So how do I turn the 3 into an 18? multiplied by 6. I don't need to multiply it by x because it already has the x squared there. Okay, so now my denominator is 18x squared. On top, this is what, 15x? And then plus this is 2x. And then this was a minus, so minus 42. So the only thing left to do then is combine the 15x and the 2x, so 17x minus 42 over 18x squared, which nothing's going to cancel, so I'm done. Okay, last two. They're not the same right now, so to make them the same, they both have an x, that's good. This 3 and 2, the smallest thing they can both go into, would be 6. So I'm going to turn them both into a 6x. So in order to turn 3x into a 6x, I need to multiply by 2. Right? I'm going to throw a minus sign in here because I need to multiply everything by 3. It might be easier, actually, if I put the minus in with the 3 instead. Sorry, I'm just going to move that to the back side there. Okay. All right. So now they all have a denominator of 6x. On top, 2 times 3x becomes 6x. 2 times 4 becomes 8. And then I have this, remember there was that minus, so I just put it with a 3. So the minus 3 times 2x is negative 6x. And then the negative 3 times 1 is negative 3. So actually, 6x and 6x cancel. So I just have 8 minus 3, which is 5, and then the 6x on bottom. So I'm done. Okay. Last one here. This is an x plus 5. This is an x plus 3. They're not the same. So remember, this is a whole factor and this is a whole factor. So I'm actually going to have to multiply the whole fraction by x plus 3 on top and on bottom. And this second fraction, I'm going to have to multiply by the whole thing, x plus 5, on top and on bottom, right? But once I do that, my two factors on bottom are just written once. And then on top, I have to distribute. So negative 4x minus 12. And this becomes what? 2x squared plus 10x. So I'm just going to rewrite that because it's squished in there. And I like it in standard form. So 2x squared first. This was a 10x and a 4x is 6x. And then minus 12. And then on bottom I had x plus 5 and x plus 3. If you wanted to go further, I could take a 2 out of everything here. So then I'm left with x squared plus 3x minus 4. I know nothing's going to factor and cancel though, so you could have just stopped where you were because negative 4 is just going to be 4 and 1, which isn't going to cancel. So either of these is fine, or you could keep going and give me the fully factored form. I just don't have space for it. But what would it be? X plus 4, x minus 1. Still have a 2 out in front. X plus 5, x plus 3. So any of these answers is fine. It is good habit to continue factoring just to make sure that nothing cancels. But for the most part, there's so much work already in the beginning, there's usually nothing that's going to end up canceling in the end. So this next page or two is your deliverable for the day. So just as a recap, up here are your steps. So you want to simplify complex fractions, factor denominators, find the LCD, distribute, then combine your like terms, and then make sure to simplify in the very end. Okay, so I'll just point out a couple things to get you started. But in number 1, they already have the same denominator. So all you need to do then is distribute this minus to both things, right? And then combine your like terms, okay? This one, you need to factor first. So this would be x plus 6, x minus 6. And then you see that this is missing an x minus 6. So we multiply x minus 6 on top and bottom. Then once you have the x plus 6, x minus 6 in the denominator, you would distribute here and simplify. So what's that? X squared minus 6x minus 72. All right, and then the reason I wanted to look at this one is because this one is tricky. That does factor. It's going to factor to x minus 12 and x plus 6. So then your x plus 6's cancel, and you're just left with x minus 12, x minus 6. Okay? Going back to number 1 real quick, you would combine these, 2x, and this is 5 minus 1. That was what, plus 4? So then you had to take out a 2. So once you take out a 2, you have x plus 2, and then on bottom you have x plus 2, and those cancel. So 2 would just be your final answer. Okay? And then, like I said, this was x minus 12 over x minus 6. All right, let's see if I did. No, I don't have enough space there. Okay. I'll get you started on the bottom 2 here since I don't have space to actually work it out. But 7, 14, 21. The smallest number I can turn them all into. I can't turn them all into a 21, so I have to think bigger. The smallest number they can all go into is 42. They all already have an x, so I don't have to worry about that, but I do have to get them to have the same number. So how do I turn 7 into a 42? I have to multiply it by 6. If I do it to the bottom, got to do it to the top. How do you turn 14 into a 42? You have to multiply by 3 on bottom and on top. And then multiply 21, or turn 21 into 42, multiply by 2 on bottom and on top. I just like to bring up the signs so that you can see them better. So your denominator is 42x, because that was the whole point of turning them into 42x, right? Then you have 6 times 2, which is 12. And then 3 times 11, which is 33. And then minus 4. So what's that become? 41? And look, here I am doing the whole problem, even though I said I wasn't going to. All right, the smallest number these can both be turned into is 9. And then this has an x squared, so they have to both be an x squared. This one I really don't have room for, so the only thing this is missing is an x. Going to multiply top and bottom by x. And this already has the x squared, so it just needs to multiply by 3. So on top you have 21, and then plus the 1x, and then on bottom is 9x squared. Which, oh my gosh, I ended up doing that whole problem for you because that's as far as you need to go with it. All right. Let's see. This page, I think you can do 7 and 8. I'm going to go ahead and look at number 9 for you because this is going to be a harder one. So when you divide, keep, change, flip, right? So you keep 4 over x minus 1, change it to multiplication, flip it so the x minus 1 goes on top and the 2 goes on bottom, and then you still have plus 3x over 1. So this one kind of combines everything we've done so far, right? So 8x minus 1, x minus 1 cancel. The 2 and the 4 simplify. So really, I just have 2 over 1 plus 3 over x minus 1, right? You want them to be the same, so I need to multiply this by x minus 1. And then my denominator is x minus 1. This becomes 2x minus 2 plus 3. And then what's that? 2x plus 1 over x minus 1. Okay, so that one's hard. Number 10, just to get you started, this whole thing is an x plus 5. It's missing an x term, so you got to multiply on top and bottom by x. Okay, the first one, 7 over x, is missing the whole term, x plus 5. So on top and on bottom, you multiply by x plus 5. All right, so then 7x plus 35 plus 6x. Combine your x's, and you're done. Okay. These are not the same right now, but if you notice, this one is just missing an x, right? They have a 2x, this is a 2x squared. It has a minus 2x, this has a minus 2. So I'm going to do 2 things. I'm looking at number 8 right now. I just need to multiply this then by x. So now they both have a denominator of 2x squared minus 2x. And then on top, what do you have? X plus 4 minus 5x. Right? So then combine these and then write your final answer. The only ones that then I haven't really done for you would be like 5, 6. So, and I'll get you started by saying, first, I want to change this to a plus and make these, change both of these signs. Because remember, when you subtract, you have to change all the signs. You also need to factor this. This is x plus 3, x plus 3. Okay? You might say, well, then aren't my denominators the same? No, they're not, because you have 1x minus 3 here, but you're still missing 1 here. All right? So do that on top and on bottom. And then once you have your final answer, you'd have x plus 3 on bottom twice. And then distribute the 2x, combine. You got it. Okay? Number 6, this is x plus 5, is missing x plus 5. So on top and on bottom. This one is missing an x plus 2. Okay. And I'm not going to do the whole problem. I'm trying to just get you started. But then you just distribute this in and FOIL this and, you know, combine your like terms. Let's see. These are already the same. So all you really have to do is combine your numerators, right? And then factor if you can. So 2x squared minus 1x squared is x squared. Minus 2x plus 1. And then factor that. X minus 1, x minus 1. And then one of these cancels. Okay. Oh, and then 8 I did on the other page, right? Yeah, I started it for you. So I've pretty much have done your whole deliverable for you, but it is just screenshot 1 through 10 on this second practice page and upload it. Okay, that's all for now.